are officially somewhat stable API. I'm very happy about that. I'm very happy to be here talking with all of you. Thank you all for coming. We also, with 1.0 release, have a shiny new website. I apologize, you can't quite see the bottom of this screen, but the others seem to be working a little bit better, so I don't have all that many lines of text on the very bottom. It should be fine. But if you want to follow along, new website, protractortest.org, complete with a lot of really much improved documentation. So if you have checked out Protractor docs in the past and they weren't great, they're a lot better now. We've got a technical writer coming in. New tutorial, it's all really, really better. So I really encourage you to check that out if you want more information. Okay, so let's actually get into it. So why do we end-to-end test? Who here has actually used Protractor? Cool, okay, that's a lot of hands. So I'm gonna kind of give an intro to what Protractor is and what it does, and talk a little bit about how Angular itself uses Protractor. And then I'll leave a lot of time for Q&A so that if people have specific questions or things they want me to get more involved in, we can talk about that. But first I'm going to do an overview of what it actually is and what the idea behind end-to-end testing is. Who's used Karma and tested Angular unit testing? Awesome, okay. So Protractor is not a replacement for Karma. I think that unit testing is always your first line of defense against bugs, and testing the individual component that you're working on is kind of easy and very important. But end-to-end tests fill a different role. And they answer questions like, does my backend work together with my front end? Do all of my components work when they're put together? What happens when I compile my code or go through a build process? Front end and back end interacting, and all this kind of accumulates with, is this thing ready for release? Can we promote to staging? Can we promote to release? And end-to-end testing adds a lot of confidence that what you are doing is actually still working, and you can catch a lot of things maybe with back-end integration much more quickly if you have an automated way of running end-to-end tests. So that's why we do it, that's why it's important. And another bit of background that I often find is useful is to talk quickly about the way that Google approaches testing. So my title is Software Engineering Test, and what that means is that I work on frameworks and help get teams set up with tests. But we're very much about developers writing tests for the things that they write, both unit tests and end-to-end tests. So our role as someone in test is to help set these things up and write examples and get stuff going, but it's actually the devs who are writing code, who are writing the tests. They're the people on the front lines with the most experience and in the best position to test that. So Protractor comes at testing from the point of view of you're going to be devs who are writing these tests, and it wants to look familiar for devs. So why is this useful? When we started putting in tests for Angular's own page, we immediately caught a bug in writing end-to-end tests. And that issue was that there's this nice little search bar up in the top for searching Angular docs. You've probably used it. If you press / you're going to get there. But it was actually listening for / everywhere. So if you tried to enter like a URL into a different input on the site, it would steal focus at the /. And no one had noticed this until we actually set up some tests. And I went up Mountain View working with the Angular team there. And like, Julie, this framework sucks. Like, things passing right away. What's wrong? And we found that this was actually stealing focus and making things fail. So this is what happens if you don't end-to-end test. The principles behind Protractor were that end-to-end testing can be really hard and really annoying, and we really want it to be as painless as possible so that devs will actually write them, because tests that don't get written or maintained are useless or more than useless, and flaky tests are more than useless. So Protractor gives you quick, reasonable setup. This is especially important because Web Framework, which is based on, is difficult to set up and not entirely coherently documented. It's trying to be very low context switching, so you can use the same framework that you use for unit testing, which is often Jasmine or Mocha, to do your end-to-end tests. having a sensible syntax that allows devs to be productive and write tests quickly, but all of this with the full power of WebDriver behind it, and always being to access the underlying instance of WebDriver and do anything specifically that you need to. And then finally giving you automatic stability so that you don't have to worry all the time about making sure that your web page is synchronized, meaning all of your requests are done, all of your timeouts have finished. And Protractor can do a lot of work there for you because it hooks into Angular. So the super quick overview of what's going on in an end-to-end test is you've got your test stuff in one process and your browser stuff in a different process. And they communicate with the WebDriver wire protocol. This is the basis of all Selenium tests. So it's really important to understand that the test process is completely separate from the browser process, and there's a very limited API that goes back and forth between them. And this API can do things like find elements and interact with them natively, like a user would. So it's sending native events to do clicking and sending keys, and using a real browser. So you can set up your application under test however you need to. It can be testing against a production instance, it can test against google.com, or it can be something on localhost, or something that you set up specifically for the test or your QA server. So it's real browsers, it's what real users would see. And in the case of Protractor, your test stuff is being run with Node.js, so you're using JavaScript, language that you're probably familiar with, but it's running in its own process and it's running through the command line. So before I go on, I want to give a quick demo so you can actually see what's going on here. So I have, is this visible in the back? Someone in the back nod or something? All right, cool. So I have a very simple application running that is a calculator that works very slowly. And it has Angular, so it has inputs that are bound using ngModel, and it's got some outputs that are bound with our little curly braces, and it has some ng repeats going on. You can set up a Selenium server however you'd like, and I'll talk about that a little bit more later, but this is a super simple way to get it going. So it's running, it's going to output a whole bunch of logs for us. And then we're going to use the Protractor command line tool. So this is a Node command line tool, and we're going to pass it a configuration file. What this configuration file is doing is telling it how to connect to this Selenium WebDriver server. Sorry, I didn't mention Selenium and WebDriver are the same project. They merged at some point in the past, so if I say Selenium, if I say WebDriver, it means the same thing. The configuration is also telling you what your actual test files, where they are, and finally, what it wants the browser to look like. So we want to use a Chrome browser right now. All right, we run those tests, and it's going to pop up an actual instance of the browser for us, and run some tests, wait for things to happen, and output the results. There's a failure here, because if you look at our test, we are loading the website, and then using the Protractor syntax that I'll talk about a little bit more in advance later to grab these two inputs and send some keys to them. So we're sending 4 and 5, we're clicking to go ahead and calculate that, and we're expecting it to be 6. You all know that's wrong, so let's change that. Go in and run it again, and here you can see values actually being put in. It's 9, all the tests pass. Quick demo, we can come back to this code later. So what we did is use the Protractor launcher and the runner to actually set up the tests and run them for us. So this is a Node module. You can install it and again install Protractor. And it gives you this command line tool that takes in a configuration file. And that config can start one or more test instances on a browser. The parallelization is somewhat new. So if you haven't taken a look at the configuration file lately, there's a lot now that you can do, saying, you know, I want to start 5 instances of Chrome and 2 instances of WebDriver, and either split my tests between these or run all of my tests on each. And one configuration file can launch all of those things. for each of these browsers, the runner sets up an environment for your test files to run in. The first thing you choose for that environment is a test framework. Jasmine is the one that we use the most internally and is the best supported. But Mocha and Cucumber are also available. And if the community wants to help maintain those, that's always something we'd love to get pull requests from. And then additionally, the Protractor environment is set up. So the runner adds these globals to your test: browser, Protractor, element, and by. And they're set up with an instance of WebDriver backing them. So this is one implementation of whatever browser you've set up to configure. And then finally, your test files run in that environment and are using those globals to actually control that environment. So here's that test that we were looking at before. You can see the Jasmine syntax is the thing that's surrounding the entire test. So we've got familiar, describe, before, get, and expectations. And then there's these globals that are specific to Protractor that are being used. So browser is for big things that you have to do with your entire page. The most common thing is to actually load in a URL with browser.get. The element function is for interacting with elements on your page, which is pretty much what the user does when they interact with your page. And I'll go more in depth in that in the next slide. And this by namespace is a set of locators that tell you how to actually find elements. So element produces a element finder, which is a special and kind of funny object that can be chained with itself and is backed by WebDriver actually finding elements. The parameter that it takes is a locator, which is just a way of finding some element on the page. So remember again that the tests are running in a separate process from your browser. So this is not a jQuery locator. This is a different, can only go over the WebDriver protocol to find an element. The most common way you're going to do it is probably by CSS most of the time. It's just finding things by class names is super easy, but you can also do ID, and then a couple that are specific to Angular, which are binding, model, and repeater. So by binding foo, we'll find that span with foo in your little curly braces, and similarly model will find any input or text area or select that's bound to a certain model on your scope. And then there's some context for dealing with repeaters and finding specific columns or rows from a given repeater. So for example, if you have by CSS, grabbing something with class form, that will find this div from down below. You can chain element to find sub-elements. So if we add another call, trying to find something by model address, that'll find that second input line there. And then we can actually do things with it. So we can clear it out in case it's got any text already in it. And we can go ahead and send some keys to it. And these will be sent natively, like native events typed one at a time. We call these actions things you actually perform with the element. So this would be either sending data to it, clearing, or sending keys, or clicking on it, or getting data back from it, finding the text value, or getting it the value of an attribute. And the way that the element finder works is you can separate these. So you can assign this element finder to a variable like address input, and then later go ahead and use it to actually send actions. And nothing, this first address input here is not actually doing anything from WebDriver's point of view. It's not requesting finding an element. It's just laying out how you will find it in the future. And this lets you do things like pull that out into a helper file. So you could make a separate helper file which exports this address input and then use that in another file, and if this form appears in various pages and you want to be able to reuse that information, you can do that really easily. And this pattern is called the page object pattern, which is a fancy name for taking the ways that you find elements and putting them somewhere else so that you can reuse them. And if your application changes, you only need to edit one place. And it makes your tests read a little bit nicer because you can put in helper functions that, say like enter name instead of sending keys. This allows you to have really clean tests, really nice. There's a lot written about it, but it's actually a very, very simple little pattern. So what this is actually doing, once it gets down to the actions, is adding a bunch of commands to a queue for WebDriver. So this WebDriver command queue is called the control flow, and everything that's happening here is asynchronous, because all of these commands have to go over to WebDriver, and that might be really slow network. WebDriver does something really slow, your app does something really slow, and the data comes back. And Protractor tries to give you a nice syntax to sort of abstract away a lot of this asynchronous nature. All of these return promises, so if you want to go ahead and put in your then calls and deal with everything exactly like a promise, you can. That's absolutely fine. But Protractor patches your test and patches the test framework's functions, so like it blocks in Jasmine, or the expect statement is patched so that it understands promises and will automatically wait for those promises to resolve before it moves on. So this specific example, when you get this address input element, you haven't put anything on the control flow when you're just getting it, because if your helper function actually sent commands, that would be really bad. But once you call that clear method, it adds a bunch. So the first one is a wait. And this is specific to an Angular application. And this is Protractor telling the application, hey, Angular, let me know when you're done with all your HTTP requests, when you're done with all your timeouts, when the page is stable, so that I can continue my test and probably won't cause any race conditions. Then it actually goes behind and finds that element, finds the sub-element, and then calls that clear command on it. And then send keys is doing the same thing, except it's sending keys at the end. So all of this gets queued up. Before your test finishes, everything's actually executed. I thought it would be useful to take a tour of how Angular uses this on its own project. I think in general that going in and looking at how a project actually runs is really informative. And we recently got this all really stable and working super well, so I think it's a very good example to follow for how to set up tests yourself. So there's going to be some tabbing on tiny screens here, I apologize. So this is Angular on GitHub. This is some source code. And this is the code for the event directives, which are click and all of that business. So if you go ahead and look at the comments, these are probably not visible in the back, but these are visible in the back. Let's make them a little bigger. All right. So in the comments, there's annotated examples. And these have two different files, an index file, and then this file named Protractor. And that's a hint that it's used for end-to-end testing. When you run build on the Angular project, so Angular uses run for build, so this would be you call run package or called before you're actually testing anything. The documentation system goes through and strips out these examples and puts them into their little separate files. And on the docs homepage, these get turned into these, and every file gets its own little tab. And this is actually running in an iframe. So you have the code for the example, and then real live example running in an iframe down here, and you can see what it's doing pretty easily. You can also, if you are running the build locally, you can see these examples outside of their iframe. So same deal, we can just increment and increment there. And what the end-to-end tests do is actually go ahead and run through these examples outside of the iframe so that everything loads up a whole lot faster. So you can start those. So let's get a Angular web server running locally. And now if I go ahead and refresh this, there we go, running on localhost. And running Protractor with the configuration file from the Angular repository. So we're going through, and we're going through all of the examples. You can see in the URL bar here, it's grabbing everything from the examples folder and running through the test again. So this is what Angular actually uses for their end-to-end tests. You can see the status of the tests on Travis, which is what they're using for continuous integration. And things are green, which always makes me happy. And if you're interested in setting up Protractor with a continuous integration server, I would definitely encourage you to start out by looking at either Protractor's own CI setup or Angular's CI setup. It's pretty useful. So, as I mentioned, we just released 1.0, which means that the API is pretty stable. This is being used by real applications inside Google and out, and I think it's in a really good place, but that doesn't mean that we are stopping at all. I have a bunch of ideas on what we're going to be doing moving forward. The first thing that is important to Google right now is talking about Dart, and you've probably at least taken a look at Angular Dart and seen what's going on there. And there's not, as of right now, a protractor for Angular Dart, but there's probably going to be something there. It's probably going to be more modular, split into the pieces that help do synchronization with the application and the pieces that help you get your servers started up, rather than one sort of monolithic command line tool. But we're really going to be looking at what people are actually needing and what the most useful features of the Protractor for AngularJS. And then just on the side of what's being written now, debugging improvements are super important. You can see that some of the little selects are opening up here because of the way that Selenium interacts with presentations. It's kind of funny, so sorry about this. So debugging improvements. So debugging web driver tests is one of the most annoying and hardest things, and that's something that I think that tools can help out a lot with. It's hard to understand where an error occurs when it might be on the back end, or it might be in your test code, or it might be somewhere on the front end. So we're looking at ways to let you iterate over smaller sections of your code so you don't have to run your entire 20-minute test suite to figure out what broke, and take a video of it and go to time point 20 to see what's actually wrong. Instead, you can maybe just run one spec over and over really quickly from your text editor, maybe. There's a project called the Element Explorer, which is a separate functionality that lets you load up a URL and just really quickly go through and see what locators would find or what interacting with a certain element would do, and then we could let you record those sessions and turn them into tests. There's a pause function that you may not have seen. So, now I've got it slightly off here. Here we go. Okay. So, let's put that in really fast. Typing one-handed. That's kind of typing. Typing the wrong thing one-handed. Okay, so I use the pause function. I'm going to save that and go ahead and run. These are the calculated tests again. So run that, and it hits pause, and it stops. We've got a little code here that's trying to tell us what it just did. So it's saying, I have executed a script recently, and we can go over to the browser and actually just interact with it. It's just a browser at this point, and try some stuff out, see what might be wrong on the page at that point, and then continue the test. And it'll fail because I changed the result there. So we're looking at ways of making that, sorry, 1 second. We lost the presentation. Looking at ways of making that more useful, helping out the wayfinding of where you are in your test when you've paused it, and maybe having some sort of REPL loop that would let you go through and actually see what the value of getting the text from an element is at that point. And then finally, we've been thinking about latency profiling. So end-to-end tests can be super slow, and especially if you're running them with some sort of remote browsers. And I think it would be really neat to be able to have something like a Chrome profile for your site that would show you what time is being taken where. So how much is just network latency, how much is your application actually being slow? Is there any latency on the side of the machine that's running the tests? So that's coming up. You can actually get a little bit of this information right now with this kind of hidden feature. If you go into your configuration and add this little show timing option to the Jasmine node options, which are the specific options for your test framework. So in this case, running with Jasmine, using the Jasmine node options. And I'll get rid of this pause statement so that my test will actually run. And let's make it fail again, so make that the wrong number. Then when we run it, instead of just seeing the error message, we actually get information about the precise point at which this failure occurred. And this can be really useful for correlating with if you have a video of what was happening during your test, or if you have logs from what the Selenium commands were, which looks something like this. This is what WebDriver has been doing in the background. It's just been executing stuff and then telling us it's done, and it gives us a little bit of information about what it's executing. In this case, getting the text. These are all of the commands that are queued up onto that control flow and then executed. And the good thing here is they have timestamps to see able to go in and correlate that. But we're looking at ways to make this easier so you don't have to be searching through your text files for timestamps. You can actually give some sort of visual output. Okay, that's all the really planned talk that I had. Here's the links for things again, and all of the code for this demo and the supercalculator is available on GitHub as well. Easy install with NPM. And now I'd just like to answer some questions. I believe we're having people come up here for questions so that it works on the recording. Or I can repeat them if you don't want to come up.
Right. So, Protractor seems like a wrapper for WebDriver. Is that like how tightly coupled is Protractor to Selenium and WebDriver? And is that going to be maybe portable into something better or something different?
So the question is, Protractor is kind of a wrapper around Selenium WebDriver, and how tightly is that coupled, and what's the possibility of porting it to something else in the future? It is very tightly coupled to Selenium WebDriver. There are WebDriver bindings for clients in various languages like Java and Python and JavaScript, which is WebDriver.js, which is a lot of what Protractor is based on. The syntax is very different from the WebDriver.js syntax to make it a lot more comfortable to JavaScript users. WebDriver.js looks kind of like someone who's trying to write Java in JavaScript. And so a lot of the ideas from that syntax could be portable, but the actual implementation is very strongly based on WebDriver. WebDriver is working to become a standard. They have a WebDriver meeting group. Google's part of this, other companies also have members in this, Facebook, etc. And there's a spec that you can go in and look at online, and I think that the usability of WebDriver is improving a lot with things like browser stack and Sauce Labs making it easier to get browsers from WebDriver in the cloud. So I don't think that WebDriver is going anywhere. WebDriver can be a pain because it can be slow and its API can be limiting, but I don't think we have better options for end-to-end tests. And I think that with the specification for WebDriver coming out, it'll certainly just become better. Yeah.
Maybe it's a good question, but if you started a project, for example, registration, what would you test from that?
It's really loud up here, so I'm going to ask you to come up and repeat your question into the mic, if that's all right.
So I have never used this technology. My question was, if you, for example, have a project that has a registration, what would you test with this solution?
Sorry, project does what?
So what can I test if I have a registration form websites with this technology?
I think a lot of the value that you get for testing like an app with a form would be, is the back end working hooked up with the front end when I actually run through things. So for something like a registration form, you would probably want to have a back end set up with like fake data, so you're not polluting a lot of middle layers of your code and UI layers to make sure that just entering a name and submitting is actually working as expected. That drop downs that might change options or change what's visible are working as expected. The errors are reported to the user as you would expect them to be, so they get the correct dialogue or whatever when what they enter is invalid. Okay.
Any big performance differences between the types of selectors, i.e. CSS, language?
The question was if there are performance differences between the types of selectors. CSS is usually using the native CSS selector from the browser, so that's pretty fast. The custom Angular selectors, so that would be binding and model and repeater. Behind the scenes, what they're actually doing is they're going in and asking the browser to run a little snippet of JavaScript, and that hooks into Angular and asks Angular to get information about bindings and models. So that's a tiny bit slower because it's actually going and running some JavaScript. But overall, the latency for WebDriver is really dominated by the network between your test and Selenium, between your test and the WebDriver server. So I wouldn't worry about it too much.
Yeah. Source Labs. We use Source Labs from Travis. I've been trying that with Cucumber.js, but haven't been finding that particularly reliable. How do you
So the question is about Sauce Labs and the reliability of Sauce Labs, especially when using Cucumber. The test framework shouldn't really matter. Everything gets converted into commands that are sent over. So Sauce Labs never sees the framework that you're using, so it shouldn't matter between Cucumber or Jasmine or whatever else you want to use. I think Sauce Labs is super cool. Some browsers have a lot more stability issues than others. Older versions of Chrome and Internet Explorer have a lot of stability issues, and in general, it slows stuff down a lot. So for Angular's test suite, it takes about 2 minutes when running locally. It takes about 10 minutes if you're running it over Sauce Labs. So a lot of the instability just comes from things timing out because they take forever. And we've been doing a lot of work lately on trying to better report timeouts, trying to make it easier to understand why things are timing out and make sure that things are cleared up properly after timeouts. But if you're having issues with Sauce Labs, that's the first thing that I would look into. That said, I haven't done a whole lot of work with other systems like BrowserStack. So I don't have a really great basis to compare Sauce Labs to other frameworks. Internally, Google has its own WebDriver server farm, which also doesn't compare great to a lot of the products that are actually available for as a service. So I can't speak much to how it relates to other things there. Let's take one from over on this side. You want to come up, use the mic? Or just yell? Excellent. I can wander this far.
Okay. Yeah, like end-to-end tests are kind of slow, basically, right? I mean, you mentioned that a couple times. And unit tests kind of test implementation rather than behavior. I think there's a real sweet spot in the middle for testing behavior in the browser, but not connecting to a backend. Now, I've done some implementation where we use HTTP backend to mock that out. Protractor does that. But anytime I Google that, the official response from the team is, actually, this is end-to-end, we don't support that. Is there any chance you change your opinion on that?
This is a great question, because it gets asked a lot, and it's clearly very important to people. So I think my answer would be, we need better solutions around, I would call this kind of UI testing, so something where your backend is mocked out or stuffed in some way. We've definitely seen that this is useful to teams, and so we're not actively working on anything, but it's definitely worming its way up the to-do list.
I see it on the roadmap.
Yeah. I think we could definitely say that this will be one of the things that's getting worked on in the 1x timeframe. Maybe not as part of Protractor itself, but as some sort of replacement for the HTTP backend hackery that kind of goes on to make it work right now, something that would be a lot smoother, or better ways of stubbing this out on the server side, so that you wouldn't have to change anything about Protractor, but you could have a really simple way of intercepting responses and replaying them, or having some really simple server that would understand that this is an Angular app and you could set it up more easily. So, yeah, this is definitely important, definitely on the radar. Anything else over here? Yes? Come up. And either yell at me or just come up.
So we're using Protractor with multiple capabilities, and we're running the same task in parallel in multiple browsers. And there's one scenario that we want to cover. Is it possible to send different parameters for different instances of the same browser?
It is not currently possible to send different parameters for different instances. There are a couple of issues with people who've gotten around this by, I think what you have is each instance has a separate capabilities object, and you can actually go in and add arbitrary information to that capabilities object, and nothing cares. So it's not technically, the fully supported way to do it, but that works pretty well. Yes?
One more question. How do you test uploading files?
File uploading. You can use WebDriver to go in and communicate with a file upload box. I believe, so WebDriver has a collection of sort of miscellaneous APIs that didn't really fit anywhere else, and it's called action sequences. So if you look in the documentation for an action or action sequences, you'll see this. And I believe that one of those has the dealing with file upload API. Protractor documentation includes all of the WebDriver documentation, so you should be able to find it there. We're also working on improvements to the documentation, the API documentation page, so hopefully there'll be something searchable soon. We've got prototypes of it, they're just not quite ready for prime time yet. Any other questions? Yes?
Is it possible to set up Cucumber to describe features scenarios, but at the same time use Jasmine to describe testing?
So the question is, can you set up Cucumber and Jasmine concurrently to describe features from the Cucumber side and Jasmine? That's not supported. To be perfectly honest, the Cucumber support in general is a little behind. It was initially a community contribution, and that has not been updated, so there may be some issues with it with 1.0. and it's not super high on the list of things that I'm completely committed to keeping perfectly up to date. That said, community contributions are great. This is an open source project. If anyone wants to help out with how Cucumber integration is going, it's a pretty small file. It's pretty readable, and I would probably accept pull requests to help with any of that. But no is the answer to your immediate question.
So I'm interested in helping out with Cucumber integration. I was thinking about this earlier. So if anyone wants to talk about Cucumber stuff later on, it's fine.
You can tell me what your GitHub handle is so I can notice it when I see your pull request and take a look at it immediately. Yes, back there.
So the problem with any language from the branches, you're kind of like after you want to start to do that again.
So the question is about using the Chrome emulator for devices. So I believe that the Chrome driver takes a list of arguments in that capabilities object, and I believe that all of the emulator options are available as command line flags for Chrome, and you can pass those in. So that should all be able to do in your capabilities object. Reader.
You mentioned that the Protractor page, to the page in the invalid state. What if we have multiple Ajax requests going on? Does Protractor know about it?
So the question is, how is Protractor doing the waiting for a stable state, and what about multiple Ajax requests? So Angular has this hidden API that is in the browser service, which is a private service, and it's called wait until no pending requests. And it's essentially a counter that goes ahead, and whenever you make a call with HTTP, it increments, and whenever it comes back, it decrements, and it does the same thing with timeouts. And that's what's used as a pretty good proxy for your pages done loading. So if you've made multiple HTTP requests, it will wait for all of those before it moves on.
So if one of them fails, it will time out.
If it fails, it won't time out. If it never comes back, it'll time out. And then you'll get a timeout that would be something like Protractor timed out waiting for your page. Yes?
So if you're using something like, say, OpenJS to make your network calls, it wouldn't be waiting for those to come back.
Not unless they're wrapped with HTTP somehow. So the question was if you're using something other than Angular to make your network requests. It would not know about that, so it would not wait for them. Yes?
So at the moment, you can access basically one document or one screen. Is there any preferences to
So the question is, you can access data via the DOM, so going in and getting text from an element, or via the scope. There's a helper function called evaluate on Protractor that will, in the context of some element, evaluate an expression on its scope. And is there a preference between those two? My general preference for end-to-end testing would be if you can do it like a user would do it like a user would do it, so generally that would mean using the DOM. But a lot of the times there's a scenario where it's just faster or easier or only available on the scope and you just want to validate something. So prefer DOM, but the other one's available if you need it. Yes?
How to find
Elements using custom, sorry. Using custom directives. Right now, there's no great way to do this. You can either write your own little snippet, which is what Protractor, basically copy what Protractor has for finding something like by model that would go in and do some custom JavaScript. Often you can get at custom directives with a CSS selector, since they'll have some sort of tag name that's pretty predictable. So I would either make a fancy CSS selector or go in and write a little custom snippet of JavaScript to be run on run by the browser. We are also, for version 1 something, probably going to introduce easier ways of finding elements with directives that aren't ng model, so like ng-click is a really common one that people want to search by. So there'll be some sort of API for those coming up.
Do you have any support for reports in CI?
Sorry, so support for reporting in CI. So the reporting is pretty much handled by the test framework, so Jasmine or Mocha or Cucumber. For Mocha, there's a whole bunch of different options. For Jasmine, so Jasmine 1.3 is web only. Mishko on the Angular team wrote this adapter for Jasmine to run with Node, and then I took parts of that and made it into a little thing called mini Jasmine Node, which is what Protractor is actually using when you tell it to use Jasmine. So the reporters for that are pretty custom baked. So there's not all that many options. It's sort of verbose or not verbose. But it is still a Jasmine API, and Jasmine has hooks for writing your own reporter if you would like to. So for example, there's like a project that has an XML reporter for Jasmine, and you can require that as an NPM dependency and go in and use that, or modify it to however you actually need the output and use that. So I would use a custom Jasmine reporter for a specific output. Any other questions? Anyone over there that I'm missing behind the pillar? Yeah.
If we don't use Angular web app, what can we still use Protractor, and what do we use?
So the question is, if you're not using Angular in your app, can you still use Protractor? You can. A lot of the custom things won't work. There is a little flag on the browser object called ignore synchronization. If you set that to true, Protractor doesn't try to do anything fancy with Angular, basically. So if you have that to false and you try to test an Angular page, you'll just get error messages that say this page is in Angular, I don't know what to do with it. But if you set that to true, it's basically a wrapper around WebDriver. So if you like the setup from the runner, you like the syntax, you like the way that it manages asynchronous requests, you can definitely go ahead and use it with the synchronization with the page turned off, and it'll be fine.
How much do we do special features of Protractor?
So the features that you use are that
that we lose.
that you lose. Sorry, are waiting until the page is stable. So in that case, you'll have to use. You probably would want to use your own system of using the wait function. So WebDriver has a function called wait. It's available as browser.wait. And you give it a condition and it basically holds until it's true. So this is often used for wait until an element is visible on the page, or wait until the title of a page is a certain thing, or the URL of the page is a certain thing. So you'll want to use that to go in and make sure that your application is stable, instead of relying on Protractor, since it won't be able to do any of that for you. And then the other thing that you would lose is the custom bindings, the custom locators for finding elements by model and binding, which don't apply outside of an Angular application. Yes?
Can we use other NPM test frameworks for Angular applications?
Can you use other end-to-end frameworks? Yes, you can. I would be very curious why, and I would love to hear what you I think a really legitimate reason to do it is if you wanted to test in a different language. So if like your backend is written in Java and your backend devs are writing their tests and they would be more comfortable writing something in Java, then they should do that. That makes the most sense. If you want to, in the course of your end-to-end test, make calls to like your database, and that's something that you could only do in Python easily, then maybe it would make more sense to be using a framework that uses Python to do your end-to-end testing. We have 2 more questions. Yes?
When you have very long page and you want to meetup, there's no current there, or you can view for it.
Could you come up and use the mic? Sorry. This is the soft voice test.
Could you just to use this question, Jen?
Yeah.
So when when you have a very long page and you try to click something that's not currently visible, it sometimes fails.
Yeah, so WebDriver has a set of rules about what it should do to try to scroll so that an element is visible. It's not super smart and it complains really easily if an element isn't visible, if it's covered by something. And I think it calculates visibility as like the exact middle of an element. So sometimes if an element is actually visible, but for some reason the middle's covered, it reports it as not. So there's some issues with this. The WebDriver stack that I mentioned earlier from the WebDriver sourcing team is trying to give really precise definitions of exactly what should happen, but not all implementations are complete with the spec yet. Certainly Safari and Internet Explorer are often the ones that lag a little bit behind what's actually happening. I believe you can, if you focus on an element, it'll try to scroll it into view. So I would try to trick it to getting where you want to on the page using focus.
At the moment I'm running custom JavaScript.
That is, running custom JavaScript scroll is also a legitimate way of doing it, but a bit of a thing. One more back here.
You mentioned a few things that are coming soon, like the element explorer. Is there anywhere that's listing like priorities and things that are coming soon?
Yeah, so the question is, what's our roadmap and how can we see the roadmap? All of the planning is done on GitHub. So there's milestones for feature requests. And those are the next version, so 1.1-ish. And then there's a 1x milestone. And then there's a kind of, this is cool, but we're not thinking about it right now. I think there's one called pending and one called icebox. That's a great way of seeing exactly what we're looking at for what's coming up next. I also occasionally talk about what's happening on G+. So if you want to follow me on G+, I don't post very much. It's not a big burden. All right?
I think that's it. Thank you very much, Julie. Feel free to hang around. There's still a few beers left at the back. Have a chat, do some networking. Thank you.
Thank you.